Hello Year 12, I just wanted to create a video explanation for question 2 of the homework. There's a couple of issues that I've spotted, a couple of common issues that have been happening on students who've handed their work in so far. The question, it looks innocent enough, cos half theta over 1 plus sine theta equals 0.825. We have to use small angle approximations to solve that. So we know, of course, that our two small angle approximations, sine theta is approximately equal to theta and cos theta approximately equal to 1 minus a half theta squared. That's for small angles when theta is in radians. We don't have any issues on that denominator there. We can just replace the sine theta with the theta. But the numerator is a little bit more awkward. We don't just have a cos theta, we've got a cos of a half theta. So we need to think about how we can change this result here. The way that it works is that whatever the angle is, cos of that angle is approximately equal to 1 minus a half of the angle squared. So we need to think carefully about how this relates to that. So if I've got, instead of an angle of theta, if I've got an angle of a half theta, I need to put half theta, but just in place of the theta there. So in other words, if I am working out cos of a half theta, that is approximately equal to 1 minus a half. So in place of theta, I need to put a half theta. So actually when I square that, you can see that I end up with 1 minus a half times a half theta squared. That, of course, will be a quarter theta squared. So that cos expression, the numerator, is actually going to be 1 minus an eighth theta squared. So what we are asked to find on approximation 2 then has now been changed into this. It's equal to 0.825. Now, a few of you are clearly thinking back to last week. Last week's work, when you were having expressions, and if I just write it in terms of x, so same expression but just with x instead of a theta, you were dealing with expressions like that, and again the words approximations were being used, but you would rewrite it like this. You would get an expression for that. So, of course, we can say that 1 plus x to the power of minus a half, 1 plus n, so n here is negative 1 times by x, run out of room, plus n, negative 1, n minus 1, negative 2 over 2 factorial times by x squared, and so on. So 1 minus x plus x squared will be that expression. So you could potentially multiply that by that, and then you end up with an expression equals 0.825, and you get a quadratic. You can find that expansion up to a term in x squared and get a quadratic. That's an approximation, but you end up with that, which isn't the answer given. The answer given is 0.206. So, I mean, it's fair enough, it's close enough, it is an approximation. However, what you've got here, it's already a quadratic, okay? If you hadn't have had the lessons last week, I think that everybody would have just automatically said, right, okay, I've got a fraction here. I can just multiply both sides by the denominator. Crucially, we couldn't do that last week because we didn't have anything on the right-hand side. It wasn't an expression. You were just given that fraction there, and you were asked to express it as a quadratic or a polynomial up to and including x cubed. This, however, is an equation. We've got a right-hand side, so you can do as you would normally do. Multiply it by the 1 plus theta. If I expand that right-hand side, 0.825 theta take everything onto the right hand side. I will have an 8, let's just put everything as decimals. 0.125 theta squared. I've then got 0.825 theta from there, and I'll have 0.825 minus 1 minus 0.175, and so what I've got there is a quadratic. And even though this is approximation, because I approximated the sine and the cos at half theta, using this method here, you've introduced a second approximation. So by expanding this with the binomial, you've got an extra approximation there. So that's why that answer wasn't the answer that is given in the solutions. So if we go to equation solver on here, you could, of course, I think if you multiply by 40, you make them all integers, but let's just type them into the calculator. 0.125, 0.825, and negative 0.175. That gets us 2 answers, we'd expect, because it's a quadratic. The first answer, 0.206. The second answer, negative, sorry, 6.806. 2 answers for a quadratic, but of course our approximation only works when theta is equal to small angle. So even though theoretically we've got 2 solutions, that of course isn't applicable. This is the one that we're dealing with. Theta is equal to 0.206. So you can see our 2 answers, you know, are very close. So this one here, when you use that further binomial approximation, 0.216. So you can see the binomial approximations work. However, doing this method, you've got 2 approximations, whereas this method, it just is that one approximation. So this would be the method that they'd be looking for. So 0.206 is your correct answer.